बुक चिकट भेटते ना.
Good evening, all of you.
Good evening, sir.
Good evening, sir.
Evening, sir.
Do we have Gen Ed students as well?
Yes, sir.
Okay, you received the link.
Yes, sir.
Yes, sir.
Good, guys. 8 seconds.
Good afternoon, sir.
Good afternoon, good evening.
तो आफ्टरनून कौन से एंगल से हो गया?
Sorry, sorry.
जो भी
Good
है.
evening.
Sir, right now we'll do exercise for remaining part, no? Correct?
Yeah. First exercise 4 we have completed up to
The 30.
30. Exercise 4 balanced out.
Sir, 34.
31.
The 31. The 35. 36. 36.
32.
The 35 नहीं 36 हाँ.
35 है कि नहीं?
Sir 35 नहीं
नहीं
36.
sir, 36 है.
36 हाँ.
36 आपने क्लास में क्या 36?
Sir, class
Yes,
को-
sir. Notes.
हाँ,
हाँ, sir.
sorry.
हाँ, sir.
38.
Sir, 33.
सर 36 निकाल सकते हो, क्लास में करा
हाँ
चुका
सर
है।
36
So 26.
32.
37 सर 37
32.
सारे बोल
सर
रहे हैं।
44 सर और 45 का सी पार्ट
45 का
सी यस सर
So we have done 45 in class.
क्या हुआ?
little bit भी किया है, only thing limits change. 45
हाँ
is
sir, right.
only
ठीक.
thing limits change. Here he asked for something else, there we took some other limits.
So 45 C part में answer wasn't matching. I saw a
We took the limits different. सुन तो लो पहले, हम लोगों ने 45 C bit limits different लिया हुआ है, क्वेश्चन में limits different पूछा हुआ. Hence answer will not be the same.
So,
Question number 31.
31 sir.
Question number 31. You have a block A and a block B. Here you have a block C.
All of mass M.
Pardon?
All of mass M only, sir.
Sir,
All block.
All identical mass M. Right. Okay. Mass M connected by spring. The system is placed on a smooth horizontal surface. Block A touches the rigid wall. Block B shifts towards the wall by distance of x and released. This is moved by a distance of x and released, so that the system moves towards the right. When the separation between the blocks A and B is maximum, block A makes head-on collision with an identical block C. Find the minimum distance between A and B after collision.
so
Natural
बहुत
length of the
बहुत
spring is L.
yes
See, first of all, what will be the velocity with which this will be moving towards the right?
we
Half kx squared equal to half mv
Is
squared.
equal to half kx square.
Yes, sir.
Yes, sir.
Is equal to x root over of k by
K by
m.
m.
Right? Now thereafter
yes sir.
you compressed it and released it, it will start moving to the right.
Yes, sir.
Thereafter
Yes, sir.
there is no external force on it.
Yes,
Yes,
sir.
sir.
Thereafter, center of mass velocity will be same.
Yeah, and he is telling you when A and B are at the maximum separation or
Maximum separation. Yes, sir.
maximum.
That time it
maximum
collides.
separation matlab initial momentum is mb into x root over of k by m. mb intentionally I am writing so that you know which mass I am referring to.
Yes, sir.
Is equal to ma plus mb into v com. This should be the velocity with which they are traveling when
Yes.
there is maximum elongation. So what will happen here? M and M will go. This will be v common is equal to x by 2 under root
K by m. Yes, sir.
This is the velocity of both A and B when V collides with C.
Yes, sir.
Now what happens is A is moving with this velocity x
B is
by
at
2
rest.
under root k by m. B is at rest.
yes
Sir,
B
but the
is at
string is
rest.
not in natural length.
Right?
Yes, sir.
Now he is asking, what did he ask? Find the minimum
distance.
Minimum
between
distance.
A and B. Minimum distance between A and B. If I find the maximum compression, answer is L minus X.
yes sir
Yes, sir.
Find the maximum compression, it will be m into x by 2 root over of k by m is equal to ma by half mu vr square use karo. Maximum compression.
yes
Sir,
sir
but the spring is not in natural length. It is at maximum elongation, right? It will be
ATM
at
में तो last length पे आएगा ना
it will be at L plus the elongation of the previous case.
L minus.
L minus.
Yes. So it is not in natural length. So how to deal with that?
So this is not in natural length. So then
Yes,
conserve
sir.
momentum. Over the ground frame. See, this is it maximum elongation, right? Maximum elongation.
Sir, it was before B like collided.
Right.
Huh.
So now it has got some elongation in it, which I
Yes,
should take
sir.
as energy. Find that elongation.
Sir, x by root 2 it is.
How much is that elongation coming? I
X by
conserve
root two.
energy. When you conserve energy, maximum elongation in this case, how much are you getting?
X by root 2.
X by root 2. First of all, did you people understand this?
Yes, sir.
Can you explain this?
We conserve the energy as this is moving.
Yes, sir.
During maximum elongation, this is colliding with us.
Okay, sir. Yes.
So this state happens when this was in maximum elongation, and that elongation is x by root 2.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So now there is some elongation in this. How much is that elongation? X by root 2. That
X by
will
root 2.
from conservation of energy of this equation. इसी equation के बाद conservation of energy लिख पाओगे?
Yes.
Yes, sir.
So you will get x maximum. So
Yes,
this
sir.
is elongation in the system when B came to rest and A is moving with this velocity. That means momentum ma into x by 2 root over of k by m is equal to ma plus mb into v common. Again, maximum compression will happen when both are moving with the same velocity.
Yes, sir.
Yes, sir.
But then conservation of energy equation will be half ma into this whole square, x by 2 under root k by m whole square plus half k x by root 2 whole square. This is the initial energy. That's the key
Yes.
catch where
Yes.
90% of you might be going wrong. Even I forgot in the first instance while solving,
Yes.
right? Because this is not the natural length. Now this will be half ma plus mb into v common whole square plus half k xm whole square.
Sir, can this be solved in center of mass frame?
Yes.
It's okay. You want to convert it into center of mass?
Yes, sir.
Sir, but external force will be acting.
Sir, but then center of mass frame it will not work out, right?
So
When it
safest
collides and
way
the wall.
हाँ सर नहीं इसमें एक्चुअली मतलब स्क्वायर्स है तो कैलकुलेशन थोड़ा लंबा पड़ता है ना
थोड़ा
सर
लंबा पड़ता है, undoubted. They
हाँ
probably they designed the problem also for that sake.
सर आई
Now,
वाज
once you get
थिंकिंग
x
कैन बी
maximum,
डन
x maximum is not your answer. That's the irony.
हाँ यस
L minus x maximum is your answer.
यस सर
Sir, how is there an external force here?
Not external.
Center.
The external force will be- This we solved with respect to ground only. See, if I am solving with respect to center of mass, half mu vr square जब ले रहे हो ना, that
Natural
vr
length
will be relative velocity of both the blocks when the spring is in.
नेचुरल
पहले प्रॉब्लम को नेचुरल लेंथ पर ट्रांसलेट करके सॉल्व करना.
ठीक है
If
सर
not, safest bet the two equations.
नेचुरल लेंथ पे करना लाइक ये आर्बिट्ररी जगह पे दिया हुआ है ना लाइक इट्स एन आर्बिट्ररी लेंथ सो उसमें थोड़ा मुश्किल हो
हाँ
रहा है
और नहीं सेफ साइड ये ऐसा ही
ओके सर
थोड़ा लंबा पड़ेगा सिंप्लीफिकेशन बट
हाँ सर इसलिए आई वांटेड टू आस्क इफ इट कैन बी डन इन सेंटर ऑफ मास
let me think about it. I'll tell you in the next class. Center
Yes.
of mass पे there should be a shorter way to bring it out, but उसमें
Yes.
मुझे भी मेहनत करना पड़ेगा.
हाँ ठीक है
Okay, sir. Sir, why can't we use half mu VR square here?
Half mu vr square you can use, but only difference is in the center of mass frame at this instant there is some elongation in the spring as
It is maximum, right? Maximum elongation.
maximum
For this
elongation
case,
for
for
this
earlier
state, not
case.
for this state.
हाँ
इस
अच्छा,
स्टेट का
okay.
मैक्सिमम elongation नहीं है, previous state का maximum elongation.
Oh, yes, sir. Yes.
So it's like playing with the legality of the question. Temporarily go by the orthodox way. I'll think of a shortcut and I'll tell you.
यस
होगा center of mass frame से भी 100% होगा. एक बार मुझे मेहनत करना पड़ेगा.
सर एक्चुअली आई वाज ट्राइंग, लेकिन मतलब ऐसा हो नहीं रहा सामने से.
Let me see. I'll try that.
Sir, that formula half mu VR square, we can only use it when the entire kinetic energy in COM frame is transferred to potential
Half
energy, right?
mu VR square is the total energy of the system when the spring has no elongation, right? Because आप सिर्फ kinetic energy ले लो.
Yes, sir.
यहाँ पर there is some elongation in the spring. तो उसको भी accommodate करना पड़ेगा.
No, sir, I'm asking in general.
Half mu VR square is the kinetic energy. उसके अलावा कुछ और एनर्जी भी अगर है तो आपको लेना पड़ेगा.
Yes, sir, equation में आएगा.
Sir, can you repeat the equation we have to use for max elongation, calculating the max elongation? That x by root 2.
Here we can use half mu VR square in the previous case.
Energy.
Acha, so energy conservation.
Energy conservation.
Okay,
You
sir.
did momentum conservation. Then do energy conservation. You know the velocity.
Yes, sir. Yes,
Energy
sir.
conservation, I'll get x maximum.
Okay, sir.
So can you re-explain the last equation once?
Conservation of energy. Initial kinetic energy of this. At this instant, there is some elongation in the spring, which
Yes,
is this.
sir.
This is the total initial energy. Final energy in maximum compression. Both will have the same velocity, and that is x maximum.
Okay, sir. Thank you.
After calculating x maximum, that will not be your answer. He is asking you distance between A and B. That means L minus x maximum will be your answer.
सर सर ये जो मोमेंटम कंजर्वेशन की क्वेश्चन आपने लिखा, सर यहाँ पे ए एम ए एक्स नहीं सर, दूसरी साइड में. यस सर. सर यहाँ पर तो वी काउंट हम लोग के पास है ना, इसका एक्स बाय टू रूट के बाय एम. तो सर ये इक्वेशन हम लोग ने एम ए के साथ वो वेलोसिटी क्यों डाल दिया?
क्वेश्चन पढ़ा है आपने?
हाँ सर.
B collides with C and comes to rest.
अच्छा, ठीक ठीक.
A is moving with the same velocity.
राइट सर. यस सर.
Question number 32. Figure shown, each tiny ball has mass m and the string has length L. One of the ball is imparted a velocity of u in the position shown, in which the initial distance between the ball is L by root 3. Initial distance, this is
So this
L
also has been
by-
done in class, I think. A similar
yeah,
one.
just a different direction we have done this.
Yes, sir.
This is moving, this is given a velocity of u. This angle is 60 degree.
यस सर.
Yes, sir.
Right? Motion of the ball occurs on smooth horizontal table when the impulse of the string, tension in the string when it becomes taut. Length of the string is L, right?
Yes, sir.
Yes,
Yes,
sir.
sir.
This is 60 degree and this is L by root 3. When will the length of the string become taut?
Perpendicular.
Hey, tan 60 is how much?
Root 3.
Root 3.
Wonderful. Then this will be L.
Yes.
Right?
Yes.
This comes here. Tan 60 will be root 3. L and L by root 3. So this is 60. So this is the instance when the string will become taut.
Yes, sir.
Yes, sir.
Initial velocity just before the string became taut is u.
You.
Right?
Yes.
Yes.
If I take this as u, if this is 60, this is 30. This will be 30, right? Do you
Yes,
resolve
yes.
correctly? Right? This is u. This will be u cos 30, u sin 30. U sin 30 will remain unaffected, but this velocity will become v. This will also acquire a velocity of v. Now this will be t delta t. This will be t
So
delta
the part that is perpendicular to the string will not remain. Oh, it's how the string is vertical. Yeah, so sorry, got it.
This is j.
Ah,
So
yeah, sir, got
t
it.
delta t. What did they ask you in this particular question? They asked
But
you
T
for
delta T only there was.
t delta t.
Yes.
T delta t is equal to both
Yes,
masses
after
are
this it can
identical.
be.
M into v, or minus t delta t is equal to m into v minus m into u cos 30.
Yes, sir.
Center of the board.
Yes.
Every year, remember when I solve, I tell the students 33rd is the easiest question. And for some reason, I keep forgetting that question. Every year when I solve, I keep thinking, what is there in 33rd? It is such an easy question. And every year I forget this question also. Two masses Nm and M start simultaneously from the intersection of two straight lines with velocities v and nv respectively. It is observed that the path of their center of mass is a straight line bisecting the angle between the given straight lines. One is going this way, one is going this way. Path of the center of mass. Center of mass is moving this way. Now, what are the masses that we'll have to take properly? Nm. This is Nm and M. Nm is moving with what speed?
V.
Nm v.
V.
V, sir.
Nm is moving with v. This is moving with
NV.
V.
NV.
So direction is not given. It's just given starting from the point of intersection.
Come again.
So the direction of NM and M is not given. It's just given they start from the point of intersection.
You have to assume now.
We have to assume it goes along the lines.
Obviously, from the intersection of two straight lines, two masses Nm and M start simultaneously from the intersection of two straight lines with velocities v and nv. Oh, your point is, will they move along that straight line, along these straight lines? Obviously, if not, how will you solve the problem?
Sir, इसीलिए नहीं हो रहा था.
Path of their center of mass is a straight line bisecting the angle between the two given straight lines. Find the magnitude and velocity of the center of mass. Theta is the angle between the lines. So this will be theta by 2, this will be theta by 2. Right?
Yes, sir.
Yes.
What did he ask? Find the magnitude of velocity of center of mass. Magnitude of velocity. He's showing you center of mass is moving along this line.
Yes, sir.
Yes, sir.
So you are assuming that NM is moving in this direction, M is moving in this direction. So he wants the velocity of center of mass. Now I'll take this along the x-axis. Take any one along the x-axis. Keep this along the x-axis. Right?
Yes.
Now, velocity of center of mass along x-axis will be Nm into V plus M into Nv into cos theta divided by
M
Nm
plus Nm.
plus N.
Plus
Velocity of center of mass along y-axis will be,
2Nm.
this velocity will
Nm
be
into 0.
Nm into 0
yes.
plus M into Nv into sin theta
Sin theta.
divided by Nm plus M. But where did we use the fact the center of mass is going along this particular direction? We'll have to take tan theta by 2. Tan theta by 2 will be VCM along y-axis upon VCM along x-axis. Am I right?
Yes.
Yes, sir.
1, 2, and 3. I don't know what is the answer given, but I always remember telling the students it's quite easy, and I keep forgetting this. 1 second, wait. Are you able to hear me?
Yes, sir.
Yes, sir.
See the answer and tell me if you're getting the answer or not.
Sir, should it not show in the VCM for y-axis? Sir, should it be like M into NV into sin theta by 2?
Yeah, this is x-axis first. This is x-axis.
No.
So this will be cos theta and sin theta, not theta by 2. Projected along x and along y.
Oh,
Sir, answer आ रहा है.
आ गया?
हाँ, sir. Yes, sir.
Someone forget this question for reasons that I don't know. But every year kids ask me this question. Tan theta by 2, substitute this by this. Divide this by this in that, you should get the answer.
So, but they haven't mentioned explicitly that it is going along the two lines only.
This catch we also never observed. See, now look at the other side of the coin. If they have not told which direction masses are moving, you cannot solve this problem.
Yes, sir.
It becomes open-ended. The masses can move in any direction. So when they said that two are along the straight line, implies they meant. Next year I'll try to get that rectified and state specifically that the two are moving along that. This is legally a very valid point.
So because
yes.
technically they can also move along the angle bisector, no? So then center of mass will necessarily move along the angle bisector.
No, both particles are moving along the angle bisector. Legally, that's a very valid point, but somehow no batch till now told me about it.
So, but
Yes.
that's a special case, no? Otherwise we assume only.
That's the bottom
We
line.
cannot
right?
actually assume as a how
Well,
it
we are
is.
assuming that they are moving along these two lines and solving and getting the answer. In the problem, we'll have to state that the two are moving in that direction. That's a valid point. Agreed. If the question would have been in a major test, we would be forced to give this as a bonus.
Sir, we can directly take their velocities along the angle bisector, right? For the center of mass.
Yes, sir. It's much shorter and the answer matches. We just have to resolve it along the angle bisector.
Yes.
That is also valid. The reason being, he's already telling you that the center of mass is moving along the direction.
Yes, sir.
Yes, sir.
He's telling you that center of mass is moving along the direction. So resolve this velocity this way, and find out VCM. Valid?
Yes, sir.
That makes more sense actually. This velocity, I'll resolve along this line. And then find out BCM because he's telling you it's traveling in the direction. Can I rub the board?
Yes, sir.
Yes, sir.
Thirty-fourth. 34th May, I have a feeling we have gone wrong with the values. You will get more than 90.
No, sir. In question, height 16 meters not being mentioned.
Yes, sir. The
Yes,
height 16 meter is not mentioned.
Yes, sir.
Height of
Getting negative 0 point the answer.
Sir, the height M.
So the
is
height
not
at which
mentioned.
the truck or whatever is there, that's not mentioned, so we don't know.
Yes, sir.
But sir, but in the on pace portal,
Let
it's
us see.
being
Have a look
mentioned.
at it. First of all, what is happening? A shell of mass 1 kg is projected with a velocity 20 meters per second at an angle of 60 degree. All that is hopes. All I need is the horizontal velocity with which it is colliding. Right?
Yes, sir.
So
Yes.
shell of mass 1 kg, 1 m cos 60 degree. Sorry. U cos 60. U is how much? 20 cos 60 into the mass is 1 kg. This is the momentum with which the shell is fired into this. Agreed?
Yes.
Yes, sir.
Yes, sir.
This is a 1 kg mass. So this will, it gets embedded into it. First of all, you will conserve linear momentum between these two. 1 plus 1 into V common. V common is equal to 20 into cos 60 is half divided by 2. 20 by 4, 5 meters per second. So technically, whole of this problem comes down to a system where this block of mass 2 kg is given a velocity of 5 meter per second. This is the problem now.
Yes, sir. Yes, sir.
A, by the way, this projectile's horizontal velocity component, right? Not an issue. Vertical velocity.
That is the issue.
Sir, वो
Sir,
maximum
it's the
height
Collide
पे-
at the highest point
Yeah,
of its range.
Yes, sir. Max
Yeah,
height पे
The collide at the
hit
highest
Yes,
point
sir.
in EM.
Sir, they have not given the height at which it collides. So we don't know which velocity.
No, they have said it
Yes, sir.
collides at the highest point of
Sir, it's max layer आ
trajectory.
गया.
बोला हुआ है क्या?
नहीं तो वो फाइंड आउट कर सकते हैं.
नहीं बोला
Yes, sir.
Length of the string नहीं दिया ना
X
यार.
max निकाल लो.
So
Length
length
of
of the string given.
So it's not given that it collides at the highest point.
It's given
Okay,
the
find
height
the
of the string is
maximum.
1 meter.
H maximum calculate करो कितना आ रहा है? H
16.
maximum will be 20 square
So 15 meter आ रहा.
sin square 60 by 2g. Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
400 into sin 60 is half. 1 by 4. 2 into
root
Sin
3.
60 is
Root
3
3 by
by
4.
root 3 by 2 cos square.
So 3 by 4.
Root 3 by 2 square means
So
3 by 4.
4.
Yes, sir.
So one, this will go 10, this will become 5. If my
15.
calculation is correct, 15
15.
meters.
Yes, sir. 15 meter correct आ रहा है.
Yes, sir. Correct. 15 meter.
तो highest point पर हो रहा है.
Yes, sir.
Yes.
So till here we are safe.
Yes, sir.
So problem till here we are correct. Other end of the string is attached.
तो
to the
highest
trolley
point
winch.
पे हो रहा है कैसे पता चला?
कहाँ से ये किधर पता चला?
हाँ वो डायग्राम में नहीं दिया है, इसमें फॉल्ट है.
They've not given anything like that. in
ऐसे
the
कुछ
question.
दिया नहीं है height
या
के
नहीं है
बारे में.
सर height of the trolley.
सर पेस की वेबसाइट में बुकलेट है ना उसमें दिया है.
M दिया गया.
सुनो मुझे यहाँ दिख रहा है डायग्राम में this is given as
M.
16.
Sir, M दिया है हमें.
One
M.
second.
M दिया हुआ है.
हाँ सर
error
वो
होगा.
16 meters. M is meters सुनो यार.
Sir, हमें सिर्फ M दिया है.
सर
हाँ,
हमें
सर.
सिर्फ M दिया है, 16 नहीं दिया है.
Printing error.
I'll
Sir, in
share
my
the screen
in my
with you
version it's
people.
there 16 meters.
Just a
Yes, sir, it's
minute.
there.
Just a minute.
एरर हुआ.
हाँ यहाँ 60 मीटर है सर.
Yes,
sir,
sir.
सही
तो
है.
उसमें 16
Yes,
meter.
sir.
meters दिख रहा है कि नहीं?
कहाँ से ये
दिख रहा है.
यहाँ पर है सर.
यहाँ
हम
पे
लोग
है हाँ.
सर ये आपने पेस के पोर्टल से निकाला क्या पीडीएफ?
मेरा जेब से निकाला यार. कहाँ से निकाला मुझे क्या पता.
नहीं सर हमारे बुक में नहीं है.
हाँ सही है, बुक में नहीं है।
Actually,
It's
नहीं है.
okay. Okay, कुछ books में print नहीं हुआ आया होगा, but now you are able to see the diagram.
Yes, sir.
Now that means can you continue and solve the problem?
Yes, sir.
Yes,
Yes,
sir.
Good, Grace. Can I stop the screen share?
Yes, sir.
Yes, sir.
Note of that height to be 16 meters.
yes,
Sir.
Balance half of the problem मैं solve नहीं कर रहा हूँ. I am assuming that you people will be able to solve.
Yes, sir.
Yes, sir.
Assignment में
Yes, sir.
balance वाला problem.
And जहां तक मुझे याद है, last year batches or the previous batches told me that the height to which the bob goes turns out to be greater than 90 degree. So they had an objection with that. Greater than 90 means it will touch the ceiling. So they
yes,
said,
sir.
sir, you will have
Yes,
to
sir.
change the values. This is what I vaguely remember. It's
Yes,
okay.
sir.
Forgive the values. You know what to do.
Sir, I guess correct
Yes,
आ रहा है.
Yes, sir. You can erase.
That was 34.
Yes, sir.
$37. This is M. The triangles are not joined. They will move the wedges. If you assume the triangles are joined, you will not get the answer. Right?
Yes.
Yes, sir. Split किया बाद में आ गया.
Striking two identical equilateral triangular wedges of mass capital. Now, mass capital. On this, I will have normal force. Reaction of this normal force is N. Incidentally, identical normal force here. Reaction of this normal force is N. This is capital M. You know how to play with the angle. This is 60 degree. This is 60 degree. Right? This was initially coming with a velocity V naught. Now I assume it is going up with a velocity V.
Yes.
Right? So if this angle is, how much will this angle be?
60 degree.
60. So 2n cos 60 is equal to mv minus of minus mv. No?
Yes.
Yes or no?
Yes.
Yes.
Sir.
Capital N sin 60 is equal to capital M into, I'll call this velocity B dash.
Yes, sir.
Coefficient of restitution is small a. Relative velocity of separation. This we are resolved in this direction. Velocity of small m minus velocity of capital M upon initial velocity of capital M minus initial velocity of small m. All of them along common.
Normal.
Velocity of small m. I'll take everything in this direction positive, in this direction negative. Stick to one sign convention. You can reverse it. I have no problem with that. Velocity of small m will be v cos 60 positive minus velocity of capital M v dash. I'm resolving in this particular direction. This will be 30.
Yes, sir.
Minus of v dash cos 30 upon initial velocity of capital M 0. Velocity of small m is, this was v naught. In this direction, v naught cos 60 minus v naught cos 60.
Yes.
That's it.
Yes, sir.
Also.
1 minute.
See, this is dirtiest thing in your batch here. Why do spammers walk in for doubt lectures? They are adding themselves as names of your classmates with unparliamentary language. This disturbs a lot. And this is one among you people who is doing. Your own classmate's name you will put, besides that name you will use unparliamentary language. Please stop doing this. ये 10th standard से जब बच्चे 11th में आते हैं, it is immaturity that they are playing. I can understand. Abhi you people have come to 12th and you are coming to the peak stage of your preparation. 100% one of you should be doing it, or you are making one of your friends do this, because the link will not be accessible to that. And such unparliamentary language. In PACE, we didn't have such type of students. We had a class apart. Right? There should be certain standards when we talk. You address one of your classmates with that language, the moment, and that guy, whoever is doing, is observing. He understands me very well. The moment I come close to the mouse, he knows I'll be deleting him. He immediately goes out. When the game is going on for some time, this is disturbing. I'm trying to control myself. Why disturb the class? Why disturb the class? The game is going on for some time. You have animosities with your classmates. You settle your scores personally, not in class. And why should you have animosity towards a classmate whom you haven't even met?
Yes.
इतना negative emotion जरूरी है हमें. Live peacefully, no यार. Stop doing these type of things. Don't. Or is it that frustration that all this spamming can be done only up to the end of this month? From first we'll be going for live classes. We will not get this opportunity. So keep spamming. क्या मजा मिलता है? Don't waste your time this way. More than time, don't let negative emotions get into your head that way. And to be noticed, no, you add yourself as one of your friends' name with an unparliamentary word besides that. To be noticed, you raise your hand so that I see that. हद हो गई है. Now 37 क्वेश्चन भूल गया अभी ये खोलना.
37 तो हो गया ना अभी.
अच्छा 38 is a good question. 38, have a look at it. This is a good question. In fact, two particles A and B of equal masses lie close together on a horizontal table and are connected by a light inextensible string of length L. I'll have to bring down the diagram to explain. I will solve half the problem. And that is the main hint I will give you. This is L. You projected this mass here with what velocity? With under root 10 GL.
Yes, sir.
If I give this mass, it was beside, I gave a velocity of under root 10 GL. That means half m 10 GL, half mv square will be equal to mg. No, I will take half mv square plus mgl. That means when it came here, what will its velocity be? Just before the string became taut. Here, both these bodies will have certain dimensions. It will not exactly come about.
Yes.
Particle dynamics.
Yes, sir.
This chapter yet rotational dynamics didn't start. They're both point masses.
Yes, sir.
Till rotational dynamics starts, we are in the subtopic of
Particle
objects. So this point object, when projected, it will come exactly above this. There are no dimensions for your body. Happy about it? You projected with under root 10 GL. It comes still here. What will be the velocity just before string becomes taut? M will go, multiply by 2, 10 GL is equal to V square plus 2 GL. V square is, sorry, 8 GL. V is under root 8 GL. The velocity just before the string becomes taut is 8 GL. Just after the string becomes taut, I will take this as V0 and V0. ऐसा कैसे ले लूंगी यार? They are two ends of the same string.
Yes.
Yes, sir.
Right? Now this will be T delta T. This will be T delta T. Did he ask you for the impulse? No.
No, sir.
So don't waste your time calculating that. Don't waste your time calculating that. Right? But suppose you want to know the orthodox way of doing it, have a look at it. I take everything in the upward direction as positive, downward direction as negative. Right? I will take minus T delta T is the impulse. Final momentum of this is mv0 minus initial momentum is m under root 8 GL. Is this part of the board visible?
Yes, sir.
Yes, sir.
Now here T delta T is equal to mv0 minus 0. Add both of them. I will get conservation of momentum equation between this mass and this mass. Taking these two masses, can you conserve momentum? I can. Why? T delta T becomes an internal force.
Internal force.
Gravity is
Yes,
non.
sir.
Gravity का क्या करोगे यार?
Non-impulsive.
Not conserving momentum between the initial condition and here. Initial condition and here का अगर लोगे, gravity will change momentum. I am conserving momentum for the time period just before the string became taut and just after the string became taut. Is the difference clear?
Yes, sir.
Yes, sir.
I am not conserving linear momentum between this and V0. Ille, no, I am not permitted to do that. This mass takes surplus time to come till here. Gravity produces substantial change in momentum.
Okay, sir.
Right?
Yes, sir.
I am conserving momentum in this state from this to V0 just before the string became taut to just after the string became taut. If I write the equation, what will I get? I'll get the same equation. Have a look at it. Just before the string became taut, m into under root 2 GL. Just after the string became taut, m plus m into V0.
Yes.
Isn't it the same equation?
Yes, sir. Same.
sir.
Balance last half of the 1/4 of the problem, I will not solve. I will leave it to your fine judgment. Somebody asked, can we solve 39th as well? I will, no problem with that.
So,
Huh.
sir, do you have any information regarding what the schedule will be from 1st March for the offline sessions?
Regarding
The schedule, sir, like the
three lectures per day, 3 lectures per day, and then doubt lecture. Only one proposal which I gave from my side, which they're consulting the other faculty and other members also is, I suggested finish the lectures by 1 o'clock and evening on Zoom you can arrange for doubt lecture. So the students can reach home early.
so that makes sense.
Oh, sir,
Doubt
that is good.
doubt
Yes,
lecture
sir,
through
it's
Zoom.
Doubt
actually
lectures on
more
Zoom evening you can take.
Yes,
Yes, sir. That is better.
They will look into the other parameters. I gave this from the viewpoint of the students and the faculty, both will be comfortable. Right? Instead of keeping doubt lecture after 1 o'clock lecture, 1 hour doubt lecture, you keep students will feel hungry, they want to leave home, they want to reach home, so on and so forth. So generally, previously when we didn't have the Zoom lectures, we used to have a doubt lecture after 1 o'clock in the wherever the faculty is. So I told them this would be feasible, but other parameters also will be taken into consideration.
Sir, in classes start at 7:30, right, in the morning?
Classes will start at 7. In fact, there were times we used to start at 7. right? We used to reach KC College in 7. The best part of the joke is when there was a terrorist attack in Mumbai, the Taj Hotel was hit.
Yes,
How
sir.
old were you people?
Yes, sir, we are
Sir,
only like
one.
Months old.
One.
We are
Months
months.
old.
2 or 3 years back.
6-7 years. 5 years.
Okay, 5 to 6 years. That day I had a class in KC College. We have an integrated tie-up with KC. You know where KC College is?
No,
Yes,
sir.
No, sir.
KC College is
Parla?
close to Trident, Oberoi.
Oh,
ये पार्ला होगा तो फिर ये
हाँ।
तू बताएगा
Right? Look at the joke. I sleep at 10 o'clock, so I don't know the news. Morning driver came, he's asking me, sir, jana hai kya? I asked him, what's wrong with you? Chalo, niklo. 7 o'clock was the class. 6:15, we get into the car, we'll reach by 7 early in the morning. No traffic. That day, generally morning 6:15, there will be no traffic. That day, all the more, there was no traffic. But then the cops stopped us in front of the airport. He started checking the vehicle and all that. I asked him, what do you need here? Why are you checking the vehicle? He asked, where are you going? I asked him, Churchgate, around KC College. What do you do? I said, I teach. He laughed. The cop laughed. He said, KC College, kaisa pahunchenge aap? Then I said, gaadi mein pahunch jayenge. He thought this guy should give a pretty madcap. He said, nahi ja paoge, wahan tak band hai rasta. Then I told him, okay, dekh lenge what. I thought traffic jam ho gaya, kuch ho gaya. Again, a cop took off. Another 10 feet we went, another cop stopped us. Again, inquiry. Then I thought something wrong. Then I switched on the FM radio. And then I got to know. And look at the irony. There are students residing in and around KC College.
yes, sir.
Now they reached the college.
Okay, sir.
And they are calling me and they tell me, sir, gate nahi khul raha hai, sir, KC College. I asked them why. I thought maybe the security man came late, ... so many things. It took me nearly 15 minutes to realize that we are actually running into a hot zone where it is completely blocked. Before I could reach even Dadar, FM radio mein samajh mein aa gaya. Then I called up those students who are standing at the gate of the KC and I told them, you people go home first, play it safe. We don't know what the situation is. Then I came home and switched on the TV. Then I got to know about the incident. Till then I didn't know.
Sir, it happened during the fight or after the fight? The attack.
ये रात को हुआ था तो सुबह इफेक्ट होगा
That
ना.
was in the night, na?
That means you didn't see that episode. That episode started at night 9:45, if I'm right.
Yes,
तो मैं सुना है कि वो एक दो दिन से था वो attack.
Huh, 2 days. And that was the only time when I saw there was zero traffic on the roads of Mumbai. Then we didn't have WhatsApp, so much of
Yes,
a
sir.
communication. So
Yes,
TV was the only means of whole day we were stuck to the TV.
You seeing what happened?
Yeah. It was more a light thriller movie running for us.
Yes, sir.
Real life
But
thriller.
a very bad show.
Undoubtedly. Just imagine if we would have reached KC College and then we were stuck up there. Because from that perimeter,
Sir,
nobody
फिर
were
2 दिन
permitted
किसी
to
कॉलेज में
come.
रहना
आप
पड़ता है.
स्टूडेंट्स को पढ़ाते रहोगे 2 दिन
We would be
तक.
stuck for
यही पोर्शन हो जाएगा.
हाँ सर पढ़ाई में बैठ जाओ
सर पोर्शन हो जाएगा
पूरा
वही।
सिलेबस खत्म हो जाएगा.
2 दिन में काम
तो
खत्म हो जाएगा यार.
गोलाबारी किसमें होगा ना पूरा.
अरे गोल्डन
एक चैप्टर तक खत्म ही हो जाएगा.
Okay, fine.
Done, sir.
Yes, sir. Done.
Sir, in this one, so the balls are together and then it is projected after. But what if they were separated by a length L, which is the length of the string? Then what would we do?
Then the geometry plays a role. We have already solved few. Look at 36th question. Then geometry comes into picture.
Yes,
To
sir.
change
Yes,
the
sir.
direction. You have already solved problems where there are two bodies this way on a horizontal surface, this given a velocity. Then the
Yes.
string becomes taut. Find out where the string will become taut. The impulse will be along.
Yes.
Till the time we have college hybrid mode allowed, so can we do that? We attend JE lectures offline but college online.
Yes, sir. Same.
You can. You can. You
There's
can.
no compulsion as such.
There is no compulsion as it is. They'll keep your doors open for online for sure, because all kids cannot be vaccinated by them. And the parents' consent is mandate. Now you can
I'm
control
saying
your
that I'll
parents'
come for
consent,
JEE
right? You
lectures,
people
but
have a control on it. So no attendance can be made completely compulsory. They first tried in Pune to make it compulsory. So the attempts from the government side will continue, but the mandatory point is parents' consent is mandatory. When
Yes.
that is within your hand.
So
Sir,
even the
11
college final
Sir,
exams
he
will try
had
to
a
keep it
doubt
online.
that we come for JE coaching, but we don't attend college lectures offline.
Yes, sir.
I know all of you are trying for that. I'm
Yes.
aware of it, in which you people do regularly. There's only one problem in it. College has a mandatory biometric system installed. This happened before the pandemic. Now, college cannot make it mandatory till all the kids are vaccinated. And now legally, you cannot say all the kids to be vaccinated directly simply because some of the kids might have got COVID. For them, 3 months of a gap is must.
And sir,
Okay.
11 final exam
but we can still opt for online or college and come for JEE offline, right? Till the time being until it is
For
compulsory.
some time period, you can opt for it. So they are working
Temporarily.
even on it. Yesterday they sent you Google Forms for filling up your vaccination details, right?
Yes, sir.
No, sir.
No,
Sir, it has
No,
been
sir,
signed.
कुछ नहीं मिला, sir.
Sir, it came.
Yes, sir, आया है.
PDF
आया
आया
है.
लेटर
अरे आया था.
Yes, sir.
आया
Open their
है.
website. They have to submit. Don't worry. They have to submit all this data to the government. It is mandatory. Nothing is done with freelancing. It is done in a proper way. They have to stick to it.
Sir, 11th final offline होगा.
Sir, online
हाँ,
delay. So
Sir, online
Get
में
prepared for
Offline
offline
होगा?
exams. Every exam will be not like today's exam.
अरे सर
sir, please.
Today's exam.
हाँ,
आज का एग्जाम वाला ब्लेड था.
कितना पढ़ा था आज के एग्जाम के लिए पता है?
Sir.
Now, this bullet is moving with a velocity 39. Somebody asked.
yes.
Now, this bullet is moving with 400 meters per second. And this is a 1 kg block. Right? 5 grams bullet, 0.005. 5 grams means 0.05 or 0.005 kg.
So 0.005.
So, my conversion is correct?
हाँ sir, correct.
Yes, sir, correct. Sir.
Force constant is 900 Newton per meter. Fine. If the block moves 5 centimeters to the right of impact, find the speed at which the bullet emerges from the block, energy lost in the collision. The block moves how much distance? 5 centimeters. 0.05 meters.
Yes.
Am I right? What is the initial momentum? 0.005 into 400 will be equal to 1 kg block will move with a velocity v0 plus bullet will come out with a velocity v. This is my first equation. I have two variables v0 and v. The bullet emerges out with a velocity v. Probably that is what he's asking you to calculate. Now, this v0 is the velocity of the 1 kg block. Half into 1 kg into v0 square is half k 0.05 whole square. It comes to rest. Final kinetic energy, initial kinetic energy, difference will go into half kx square.
Yes, sir.
Which can two equations, two variables. Energy lost in the collision, you know the total initial energy, half mv square. You know the total final energy. Final energy is this. It comes to rest.
Okay, right. ठीक है sir, ठीक.
बहुत इरिटेट था इसका कैलकुलेशन. पॉइंट्स में था इसलिए बहुत गुस्सा.
Who asked 44?
So
This class.
we have done 44, right, in class?
Yes, sir, classroom problem.
क्लास में किया.
People don't pay attention in the class.
तो क्वेश्चन सॉल्व कैसे करते हैं सर?
क्या?
Sir, if they do not pay attention in class, how are they able to solve questions?
44 पूछा क्यों है बंदे ने जब क्लास नोट्स में इन डिटेल किया हो. और ऐसा भी नहीं कि जल्दी भागे. वो प्रॉब्लम देके I waited. There is a catch in the problem. Relative velocity is 0.
Yes, sir.
Yes, sir, because it's
So I
downward.
gave the problem to you people. You people attempted it in the class.
Done, sir.
सर
बोलो।
सर आप खारघर में वीसी लेक्चर्स लेते हो?
अगर में वीसी नहीं लगाएंगे, जूम लेक्चर्स ओनली, द ऑनलाइन लेक्चर्स, जिन बच्चों को ऑनलाइन लेक्चर्स अटेंड करना है, they can attend online. In our timetable, we'll have one lecture or from that digital board. From there, you will be able to attend the Zoom lecture wherever you are.
But VC lecture is possible.
So if we'll come offline, then also we'll get the same track of teachers.
Naturally. Offline, Andheri, Dadar will stick to the same line of teachers.
Both tracks.
Both tracks, almost.
Okay.
Maybe there will be very minor changes, but it will almost be the same. I will know the timetable 1 week before you people, exactly. Right?
Okay,
When
so
you
send
ask
it to
me, I
us.
will be able to give you a much better idea.
Okay, sir. सर आप हमें भेज ही दो ना WhatsApp.
वही direct timetable भी भेज दो ना.
बहुत बढ़िया बात.
Now listen. Today I am also tired. I also took a test from 3:30 to 4:15.
Yes.
Right?
Yes, sir.
Yes. So
Yes,
exercise
sir.
1, tomorrow's class, last half an hour, I will discuss few problems of exercise 1.
Sir, exercise 3 was
Exercise
sorted
one,
out.
sir.
Exercise 3 to 1 is last problem is
Okay,
pending.
okay, whatever you people say. Right? Tomorrow morning we have one lecture, right?
Yes, sir.
Yes, sir.
Done. So tomorrow morning, last half an hour, we'll deal with some doubts. That way we'll finish off this chapter. Don't
Sir,
worry.
do you have a lecture with us tomorrow, Zenith के साथ?
Yeah, है.
Yes.
अच्छा,
12 बजे है.
ठीक है सर.
ठीक है सर.
हाँ sir. Okay sir.
Thank
You
you,
can send
Bye,
today's
sir.
recording.
Thank you, sir.
Bye sir.
Yes, sir. Can you please send the recording?
Okay, okay, I'll send.
Thank
And
you.
sir,
Thank you,
yes,
sir.
वो Wednesday का lecture का recording है आपके पास? थोड़ा सा बीच में disconnection हो गया था, इसलिए I missed the
Date और
square
time
thing.
भेज दो.
Group पे ही send कर दो, आप group पे send कर दो. People were asking today also, I guess, on the group.
So date और time send करो, वो lecture retrieve करके भेज दूंगा.
ठीक है sir.
Thank you.
Group में ही पूछ लो.
हाँ और सर ये lecture का
Okay, ये भेज दूंगा for sure.
सर आप कल के जो ज़ेनिथ बैच उनके ग्रुप उनके बैच में क्या डिस्कस करोगे? Sir,
Sir, in the last question we read right now, the spring force would be an internal force, right, to the system, that in momentum conservation, or will it be non-impulsive?
Non-impulsive.
Non-impulsive. Okay, sir.
Thank you,
Powai,
sir.
somebody is asking about Powai. About Powai, I have no idea. I'll have to see or talk to them, then I can tell you. 1 week before March 1st, I will have some idea.
Do you have any idea about chamber bench?
I'm telling you, last 1 week, I'll have some idea. I keep going to Andheri Center regularly. So 1 week before, I will have some idea.
Okay, sir.
Bye, sir. Thank you,
Bye,
sir.
sir. Thank you, sir.